Yeah, good evening everyone. Welcome to my session. Today we are going to discussion about softening of water by ion exchange process. Yeah, the ions can be exchanged by some kind of resins we are using to eliminate the excess of ions or excess of minerals. We also known as generally we known as a demineralization process. This process is we call as a demineralization process. Means it is a removing of excess of minerals can be removed for this process. Here we can use it as a resin. Here in this process the cross-linked long chain organic polymers can be used as resins. Here some acidic functional groups containing resins and some basic functional group containing resins are there. Here resin is having the microporous structure because we have to exchange of ions here in this process. So in this technique we are using a method also there. Here the some chambers, two chambers we are taking here. One is cation exchange resin chamber, another one is anion exchange resin chamber here there. Hard water here inlet with hard water, pumping with hard water with cation exchange resins. The ions will be exchanged. Okay, cations will be exchanged here in this process. Here the granule bed is there. The excess of impurities will be removed from this here. Okay, the wastage water will be go out of this pot, and here the resin, here the making of new generation of resin is there, because the additional we are the acidic solution we are taking here the regeneration of resin we call as a regeneration of resin. That is a cation exchange resin. Okay, hard water with some kind of cations will be exchanged here, and softening of water and pumping with anion exchange resin containing chamber, it will be exchanged by the anions and ions. Okay, excess of minerals will be exchanged in these two container. Okay, these two container, hard water will be converted to the soft water. Yeah, the same as this method. Okay, this is the alkali solution is there, KOH or whatever it may be. Here the acidic solution we are taken as H2SO4 HCl solutions to regeneration of the ions. This is the one kind of process is there. Okay, softening of water by ion exchange method, but hard water will be converted to soft water here. Here the two methods are there. One is a cation exchange resin, another one is a anion exchange resin. Here in this one, the cation exchange resin, okay, cation exchange resin is containing we are taken as a styrene divinyl benzene copolymers. Okay, styrene divinyl benzene copolymers can be used to cation exchange resin. Okay, here in this process this styrene divinyl benzene copolymer will be sulfonation. On sulfonation will give the styrene divinyl benzene copolymer sulfonic acid. Okay, that is the sulfonic acid. Or in styrene divinyl benzene copolymer on carboxylation, we will get the styrene divinyl benzene copolymer carboxylation, polymer carboxylation. Indirectly, carboxylation is means styrene divinyl benzene carboxylic acid. Okay, benzene carboxylic acid is one kind of polymer. Carboxylic acid means it is containing acidic functional groups. Acidic functional groups releases the H plus ions. Acids can releases the H plus ions. It will be act as the acid, resin acids. Okay, here the one kind of polymer it is. Okay, here the exchanging of their H plus ions with water. Obviously, we are exchanging the H plus ions. Where the cations can be removed. Okay, cations will be producing of cation. Okay, ion. It will be exchanging of resins will be binding with some metals, and the making of hard water to soft water. How it is going on here? We are taken as a RCOOH is the RCOOH means it is a resin containing resin. Okay, resin, that is we are using as styrene divinyl benzene copolymers on sulfonation, on carboxylation. Sulfonation we will get the sulfonic acid, carboxylation with the this carboxylic acid. Carboxylic acid means resin carboxylic acid. Okay, it produces the H plus ions. Is resin carboxylic acid bind with reacted with calcium bicarbonate, resin carboxylic acid magnesium bicarbonate. Sometimes we can write RH factor. Only RH factor means resin carboxylic acid we are taken as a resin with H hydrogen. Okay, it releases the H plus ions only. Okay, we are taking generally we are taken as a H plus ion, releases the R minus H plus. Okay, that is here the temporary hardness of water. We have two kinds of water is there. One is the temporary hardness, another one is the permanent hardness of water. Temporary hardness water is caused by the bicarbonate ions. Okay, permanent hardness of water caused by calcium chloride and calcium and magnesium, it's chlorides and sulfates. We know that one. Okay, here the same, we are the removing that ions, removing that hardness caused by water, which metals are there, that will be removing of excess of metals we can remove from this process. Any kind of metals will be bind with these resins, carboxylic acid containing resins, any kind of metals will be exchange of this process. Excess of minerals means demineralization process, means we are the removing the excess of minerals. Okay, that is RH factor. Here the reacted with MgCl to RH, resin containing acid. Okay, resin containing carboxylic acid, resin carboxylic acid reacted with calcium bicarbonate, resin carboxylic acid reacted with magnesium bicarbonate, resin carboxylic acid reacted with calcium chloride, resin carboxylic acid reacted with magnesium chloride. Here the resin carboxylic acid with magnesium sulfate with calcium sulfate. Okay, whatever the impurities of the compound means odd water containing compounds are there, that will be reacted with these resins, the making of the removal of the excess of metals of ions or whatever it, removal of excess of ions. Okay, let's see here the calcium bicarbonate, the resin will be bind with R minus COO. Okay, COO minus H plus. R minus means here R COO minus H plus. Resin carboxylic acid means COO minus H plus. This COO minus bind with R2Ca, means we have the resin will be bind with calcium metals. Okay, resin with bind with magnesium, resin with bind with calcium, resin with bind with magnesium, will be like that. Here the making of H plus ions will be bicarbonates, HCO3 minus and H plus will be bicarbonate. This is the carbonic acid. H2CO3 is nothing but carbonic acid. Here the making of carbonic acid, bicarbonate releases the carbonic acid. This carbonic acid is highly unstable, it's very easy to remove the CO2 gas and with water, the formation of water. Here the same, here the H plus with calcium chloride, this H plus reacted with Cl minus ions, the making of HCl, and sulfate, this H plus will be reacted with SO4 minus ions, making of sulfate, H2SO4, acids, the formation of the acids. Okay, the resin will be bind with metals, the calcium magnesium metals. Okay, and here the making of acidic solution. This acidic solution, these acids can be removed from anion exchange resin. Here the anion exchange resins we are taken as a phenol formaldehyde or amine formaldehyde resins. Okay, phenol formaldehydes and amine formaldehyde. Phenol means OH group containing compounds. Amines means NH2. These are the basic in nature. Okay, these are the basic in nature. Basic will be abstracted with H plus ions. So already we are the acidic solutions are also there. Acidic solution is nothing but releases the H plus ions. Okay, we know about that one. This when we react with alkali resins means anion exchange resins. These alcoholic resins reacted with acids, the formation of neutral compounds. Okay, that is the process is there. ROH reacted with HCl, the making of RCl, resin chloride with water. Okay, ROH, resin alcohol, will be reacted with H2SO4, R2SO4 with water, making of salt with water. The indirectly we can producing of this salt. Here the another one process is there, the regeneration of the resins. Why the importance of the regeneration of resins means, if it is a completion of the resins, okay, when we are taking some amount of resin, okay, if it is completion, there is no process will be, ion exchange process will be continuous taking place. So that is we are going to bulky, means it's a huge amount of water, hard water will be exchanged with ions. So that's why the big containers we are taking as big container, it's enough to cation exchanges and anion exchanges. So we are regenerating the resin. So when we are taking with acidic solution, We are the R2Ca. The making of R2Ca again will be reacted with HCl. This R2 can be making of RH. Okay, regeneration of resin carboxylic acid. Okay, here the R2Mg. Okay, resin magnesium will be reacted with H2SO4. The making of resin sulfonic acid. Okay, resin sulfonic acid with magnesium sulfate, calcium chloride will be same as it is. Anion exchange resin will be alkali solution we are taking here. RCl, here the making of RCl, RS2, anion RH, R2SO4, R2HCO3 bicarbonates, the resin bicarbonates, resin sulfates is there. Here the RCl, resin chlorides will be reacted with sodium hydroxide, the making of resin alcohols. Okay, the NaCl, okay, salt. Okay, the making of bicarbonates, same. ROH with sodium bicarbonates, whatever it may be, the regeneration of the resins will be, the process is going on same method with cation exchange resins with anion exchange resins. Okay, this is the hard water will be converted to the soft water. This process is known as a ion exchange process. It's very simple and very easy. Okay, don't think it's not hard. It's very important question. It is also, it can be used to, merits also there, it can be used to soften highly acidic solution and alkali solution. Its produces of water is very low hardness, that is a 2 ppm. Okay, 2 ppm, very good for the treating of water for use in high pressure boilers, but it is a demerits also there. So very expensive and more chemicals will be needed, and turbidity must be low at 10 ppm. So 10 ppm water can be purified by this method only. If it is turbidity is more than 10 ppm, we can't, this process is not useful for the not useful means it cannot be purified by the ion exchange method. Okay, it will be containing some of the high ppm we will get. Okay, high impurities we will get. So this must and should, the turbidity must be low 10 ppm only. Okay, low 10 ppm, below 10 ppm. So that's why we are using as a granule bed also, because some of the turbidity of will be stay there. So that's why the completely we get the demineralized water. The excess of minerals will be removed from hard water, will be converted to soft water in by ion exchange process. Ion exchange process we are using of the some kind of resins is there. The acidic resins also there, and basic resins we are taking as a basic resins and acidic resins. Acidic resins are used in a cation exchange resins, and basic resins we can use it as a anion exchange resins. Okay, this is the one of the important question it is. Okay, thank you so much.